So in this video we're going to do separation of variables again, and the integration is going to involve a logarithm. So we have the differential equation x times y prime equals negative 2y. So if I rewrite that, I get x times y prime is the same as dy dx, and this equals negative 2 times y. So if we multiply both sides by the dx, we'll get x dy equals negative 2y dx, and we haven't separated variables yet because right now I have a function of x times the dy and a function of y times the dx, so we want to get the y's with the dy and the x's with the dx. So if I multiply both sides by 1 over xy, so multiply both sides by 1 over xy, we get x divided by x is 1, and we're left with 1 over y dy on the left hand side. And we get y divided by y is equal to 1 as long as y isn't 0. So we wind up with negative 2 times 1 over x will be left dx. And just kind of paying a little bit of attention to this right now. We see that y can't be 0 and x can't be 0 because we're dividing both by x and y. So right away we have some restrictions on the domain and the range. And then what we do next, because we've separated the variables, all the x stuff is with the dx and all the y stuff is with the dy, we just integrate both sides. And when we integrate both sides, we recognize that we get a constant of integration that comes out of the integration process. And the negative 2 inside the integration sign is a constant, so I can actually factor that negative 2 out of the integral. See if we can make that symbol just a little bit better. So factor that negative 2 out, and then we'll go ahead and integrate. So the antiderivative of 1 over y is the natural log, and we need to remember to put the absolute value of y. And this will be negative 2 times the integral of 1 over x dx is going to be the natural log of the absolute value of x, plus a constant of integration. And then this one we don't need to leave it we don't need to leave it implicit. We don't need to leave it so that y is implicit. We can explicitly solve for y. So we raise each side, we make each side an exponent base e. So we do e to the natural log of the absolute value of y, and e to negative 2 times the natural log of the absolute value of x plus c. And then we want to recognize that when we do e to the natural log, that these are inverse functions, so the absolute value of y will fall out of this. And then what we want to recognize is that we can actually drop the absolute value symbol on the y here, because base e to an exponent cannot be a negative number, so we don't have a need for the absolute value symbol there. And then we also want to recognize that the right hand side can be rewritten as y equals e to the negative 2 times the natural log of the absolute value of x times e to the c, right? Because when we multiply same bases, we add the exponents. So here I have an addition of exponents, which means it can be rewritten as the product of the bases raised to those exponents. And then we want to recognize that if we have e to a constant c sub 1, that this is just Euler's number to a constant, which is just going to generate another constant, another real number, call it c sub 2. So we can actually rewrite the e to the c with just c. We can say, hey, there's a constant of integration that we get, or constant that we get by raising e to the c. And then the convention would be to put that constant in the front. So y equals c e to the negative 2 times the natural log. And we can push this even a little bit further. We can use properties of logs to say this is e to the natural log. I have a number in front of the logarithm, or being multiplied to the logarithm. So using log properties, that can move up into the exponent position on the x. And now I have e to the natural log, so those are inverse functions. So we get y equals c times the absolute value of x to the negative 2. And then we can ask the question, do we need the absolute value symbol here? And what we want to recognize is that x to the negative 2 is the same as 1 over x squared. And if we're squaring the x will never be negative. It'll always be a non-negative number. So in fact, we can drop the absolute value symbols, and we just get cx to the -2.